Natalie, so I don't know how much you know and how much you don't, but it's always good to use a graphical representation. This is a fantastic tool. It's called Desmos uh, Graphic Calculator, and visualization is always the easiest way. Now, as you probably already know, a quadratic is also called a parabola. It can face up, or if it has a negative number in front of it, it'll face down. So negative numbers in front, leading coefficient will face down in front of the x squared or in front of the factored form. And these are the three different versions of a parabola, a quadratic. This is called the factored form. What can we learn from the factored form? We can learn where it crosses the x-axis. So if I look at negative 2, I make it plus 2 instead. And I discover it crosses the x-axis at plus 2, comma 0. Why 0? Well, at the x-axis, y is always 0. Learn this, learn factored form, it's going to come up again and again and again. Then the x minus 4, if I reverse minus 4, it's plus 4. That tells me the other spot is 4 comma 0. What can we learn from this? Well, where it hits the x-axis is when y is 0. That's the only time we can factor something, when it hits the x-axis. But the other thing we can learn is what's the distance between plus 2 and plus 4? Well, you can add them together, 4 plus 2, and divide them by 2. That's how you find the middle point of any two lines. 4 plus 2 divided by 2, so 6 divided by 2 is 3. We discover that the axis of symmetry is at a point called x is equal to 3. By the way, when I make x equal to a number, we always get a vertical line. There's the axis of symmetry. If I wanted to cheat and find out the vertex, what's the vertex? The vertex is either the lowest or the highest point. In this case, this is the vertex. But the axis of symmetry also goes through the vertex every time. So since I know my axis of symmetry is halfway between my x-axes, I could plug this 3 into the equation, into the factored equation. So 3 minus 2 is 1. 3 minus 4 is minus 1. Plus 1 times minus 1 is minus 1. So I discover instantly that my vertex is 3 comma minus 1 by finding the axis of symmetry. So there's a lot to be gained from the factored format. As a matter of fact, the distance between any 2 points on this line, for instance, the distance between this point, 1 comma 3, and this point, 5 comma 3, if I take the average of 1 on the left, the x of 1, and add it to 5 and divide it by 2, that's 6, divided by 2, 3, I get the axis of symmetry. So any 2 points along the same y-axis will also give me my axis of symmetry. I like to cover this because it's important to understand what function each of the formats has. Then there's this version. It's called the vertex format. Why? Because if we look at this and make it plus and then just leave this as it is, we discover the vertex is right here in the formula. 3 plus 3 comma minus 1. So that's the reverse. For x, it's the reverse, so plus 3 minus 1. This is called the vertex format because we can see the vertex right in there. Its really only function is to find the vertex. However, if we were to expand it, if I were to expand this, this is the same as x minus 3 times x minus 3 minus 1. I would get this expanded form. This is called the standard form. The standard form, here we go. The standard form is the only one we would use for the quadratic. Now, you're always going to factor first for quadratic equation. But I want to show you that it will work even when you don't have the factored, when you already have the factored format. But before we get on to it, here's the quadratic equation right there. We're going to use this one. There we go. You must always use the standard format for the quadratic equation. And let's have a look. Here's the quadratic, and here's the crop. There we go. There's the quadratic. Now let's go back to our standard graph here, and we discover, okay, the standard format is right there. Notice that the quadratic here, this particular quadratic, crosses the x-axis in 2 spots. But I also want you to notice that quadratics either cross in 2 spots, but they can also cross in no spots, but they can also cross in, oh, hang on. I'm trying to figure this one out. Plus 8. So if I add one more, plus 9. There we go. It can also cross in one spot, and that's where the discriminant takes place. So keep this in mind. A quadratic can cross in no spots, one spot, or two spots, and that's where the discriminant is going to come in play. But let's work with what we have here. We have this. This is our standard format. And we're going to take a copy of it. And I want you to remember that the vertex formula up above gives us the vertex, so we'll keep the vertex around as well. So here we go. We have our standard formula. And we have our quadratic. And I want you to focus on the standard right here in this red box. How do we identify A, B, and C? How do we identify A and B and C? Well, when there's no number in front, that's actually a 1. We never write the 1. The number, that would be our A. It's the first number in front of our x squared. Why is it important to memorize that's in front of the x squared? Because sometimes they'll be tricky, and they'll give you a line in the wrong order, like this. And you'll instantly say, oh, well, the A is, you'll make the mistake and you'll say A is 8. But you must place the quadratic in order of highest power of x, next highest power of x, and then a number. So this one here, that is not A. It must be arranged in this order. There's the x squared is first, the x is next, and the 8 is next. The number is next. They'll give you lines like this sometimes in the wrong order. And you cannot use the quadratic formula until you figure out what's the right order and what is A, B, and C. So A is always the number in front of x squared. Then B is always the number in front of x. So in this case, B is equal to minus 6. And then finally, the numerical value, which sometimes is not there. Sometimes there's no number there, and C would be equal to 0. But in this case, C is equal to 8. So we discover this connection here. B is this number, C is this 8, and A is this invisible 1 in front. Now, if it was a negative number, you put the negative in there. Now, let's look at the discriminant. What does the discriminant tell you? Well, what do you know about square roots? This is the discriminant here. We know that you cannot square root a negative number. You cannot square root negative 8. So that means if this entire thing in here comes out negative, it means the quadratic does not cross the x-axis. That's what it means. So that's why we waste time with the discriminant first. If we get a negative, if b squared minus 4ac is negative, we don't have it crossing the x-axis. Let's put it in for what we do know, and we'll do some more examples. Always help to be graphic and use the exact examples. We know that b is equal to minus 6. What's b squared? Well, minus 6 squared, any negative number squared is going to become a positive number. So that means b squared is 36. So we're going to write it as this. B squared is equal to plus 36. A, we know, is equal to 1, and C is equal to 8. We just take all these things, and where I see b, well, I've already done the b squared, right? So I'm going to replace the b squared with 36. I've done the 4, and then I put in the a, which I know is 1. Always try to put also your letters in brackets. So in case it's a negative number, it's quite clear what's going on. But in this case, we're working with just a 1. And then the c we replace, which is the 8. What's 4 times 1 times 8? It is 32. So negative 32. Negative 32. What's 36 minus 32? It's 4. It's 4. Notice that this square root is a perfect square root. That's why it's not practical for this solution, because it has the exact values. But notice that this is a positive number, isn't it? It's a positive number, plus 4. When you come up with a positive number that isn't 0, that means there's 2 roots. What's a root? It's the x-intercepts. That's a root, and that's a root. Interestingly, we say the root's the opposite of the factored form. These are the factors, x minus 2, x minus 4, but the roots are plus 2 and plus 4. So the roots are the opposite sign of the numbers of the factors. So in this case, the root of this is 2 and 4. X is 2 and x is 4. Whereas the factor is x minus 2 times x minus 4. Just a little thing. Well, we discover that our discriminant is plus 4. That means I have 2 roots. Now if I continue, since I found a discriminant that's positive, I know I can continue on and use the quadratic formula. If I'd found a discriminant that was not positive, if it was negative, I would not continue, and I would just say there are no roots. There are no roots. But this is a positive 4. Let's fill in the rest. So I have this negative here in the quadratic. Count that as a separate thing. That's why I say leave all your signs in there and put them in brackets. Put all your letters in brackets. Leave all the negatives in the formula as they are. Now, that means this negative goes in front of whatever b is. What does the plus minus mean? It means we're going to do 1 that's plus, minus b, minus, come on, minus b, plus the discriminant, which we know is b squared minus 4ac. I might as well keep a clean copy. So we know we're going to do one version that's plus and one version that's minus. So we're going to just do this version that's minus and this version that's plus. Well, let's keep that negative sign separate. Let's try to remember what our b was. Our b was minus 6. That's why I like to keep it in brackets. So wherever I see b, I'm going to replace it what I know my b is in the formula. It's minus 6. Well, this minus out front of this minus 6 is separate. It's part of the equation. So it's multiplying the minus 6, which means it's essentially a minus 1 multiplying the minus 6. Minus 1 times minus 6 is positive 6. The discriminant we already figured out. 6, positive 6. The discriminant we already figured out was 4. Remember, it was b squared, which was positive 36, minus 34. So that comes out as square root of 4. What's the square root of 4? Interesting, for the square root of 4, there's two answers, but we're just going to work with the one. Square root of 4 is 2. Right? So we got all this up on top. 6 plus 2. What's 6 plus 2? It's 8. And we're going to do another example. 6 plus 2 is 8. Now we've got to do 2 times a in the bottom. And again, if a was negative, that's why you should put it in... I can't hit the right key. There we go. 2 times a. And we notice that a is positive 1, which makes our life easier. So we put 2 times 1. 2 times 1 is 2. 8 divided by 2 is 4. This tells us one of our roots is 4, not our factor. Remember, the root's positive. One of our roots is 4. Now we're going to go over to this one. So minus b, again, b is on its own separate minus 6. So we get minus 6 in there, and we have a minus multiplying the minus 6. It becomes plus 6. So the negatives in the equation are separate from the negatives in front of the numbers. Then I've got it, this time I'm subtracting my discriminant. We already figured out our discriminant is 4, square root of 4. We also know the square root of 4 is 2. 6 minus 2 is 4. 6 minus 2 is 4. And then 2 times a in the bottom. This time our a is 1. Right here, there's our a, 1. 2 times a is, 2 times 1 is 2. 4 divided by 2 is 2. And we discover our second root is x is equal to 2. This makes perfect sense when we go back to our graph. We discover, sure enough, there's one root, x is 2, and one root, x is 4. Notice that the quadratic formula gives us the roots. So we've discovered these two things, these two roots. If you were then to ask to put it in factored form instead, you do this. Y is equal to a. You have to put a because you don't know if there's a number in front. And you do x minus 2, x minus 4. Interestingly, this is the standard format of the factored format with the a. To figure out a, you would need any point on the graph, which we have, other than the x-intercepts. We could use the vertex, right, to figure out a. For instance, in this case, we don't do it because we were given the formula, but if we were asked to figure out the formula after finding the roots, we know the vertex is minus 3, is 3. Is it 3? Let's go back and look. And, okay, here we go. Sorry about the interruption. So that's great for this one, right? We've discovered the roots. It was pretty easy. Let's look at a couple that are not so easy, and it's the whole point of the quadratic and the discriminant. Let's have a look at just a random one. Let's make it downward facing. And we can clearly see plus 4x plus 2. We can clearly see that this has two roots, and they're not quite even, are they? They're not even numbers. We can also see it's downward facing. But that's information that we know, and it helps us, right, when we're studying to know what's the actual answer. So please, I encourage you to use Desmos. To get a square, you do Shift 6, and it will draw it for you, and it will really help you study. Notice the vertex is also really weird. So we're going to use the same technique. We're going to identify A, B, and C from this, and there we go. And we're going to use the quadratic formula. All right. So I notice it didn't quite get a good thing, so I'm going to try that again. I believe what's going on is it's taking an image. As I grab the image from there, there we go. We'll try this again. There, that's the one I want right there. Good. Right. Now, let's see if you can pause and identify what's A, B, and C. This is the standard format, so it's pretty easy to see, right? All right, you should have it by now. A is in front of the x squared always, so A is equal to minus 3. B is in front of the x always, so B is equal to 4. And C is the number, if there's a number. So now we have these. Now remember, when we do the quadratic, we're doing two versions, but let's focus on the discriminant first. We might as well figure out what B squared is. Well, since B is 4, B squared is 16. So we can just put a 16 where we see B squared. All negative numbers squared will become positive. So we do that. Then we just got to, I like to put them, as I say before, in their own brackets. So we've got bracket A, bracket C. Well, 3A is minus 3. That's why I use a bracket to see what separate my negatives. And C is 2. What is minus 4, which is this front one, times minus 3 times 2? Well, a minus times a minus is a positive. So you get positive 12, and then times 2 is positive 24. So that becomes positive 24. Right away, you should notice that your discriminant, 16 plus 24, is a positive number. It's square root of 40. As soon as we see that this number in here is bigger than 0 and positive, we know that there are two roots. Don't worry, we'll do another example. But that means I have this as square root of 40 as the discriminant. I may continue now. Just remember the discriminant square root of 40. Okay, now remember that there's always two answers. There's going to be a positive answer and a negative answer. That's what that plus minus red thing is. So we're going to do one with a negative and one with a positive. Also notice that this minus is separate from the formula, and I like to put my things in brackets in case they're negative. It reminds me to multiply the negative times the negative. But in this case, B is just 4, so I get negative 4 up front. We also already figured out our discriminant. Our discriminant is square root of 40. And I want to make a point here before you solve this. 40. And then 2 times A, we've discovered that A is minus 3, and this is why I like to put all my letters in their own brackets. A down here. Well, that's 2 times minus 3. 2 times minus 3, positive 2 times minus 3 is negative 6. Now my point here that I want to make is that this is so now we have a negative number here and a negative number here. So the negative divided by a negative becomes a positive. And you never have a negative in the denominator, by the way. If this had been positive up here and negative down here, we would float this negative number up to here and just put it in front of the 4, because we never have a negative down there. But it's not. The two negatives cancel out, and this is our accurate answer. Now, the reason this is the most accurate is because as soon as we take a square root of 40, we're going to get a bunch of decimals that go on way too long, and you start to introduce inaccuracy, whereas the term square root of 40 is exactly accurate. So if you have a teacher who asks you for the exact roots, this would be it. And actually, you can simplify this. If I'm going to go a little complicated, you can skip this if you want. But this technically is 4 over 6 plus the square root of 40 over 6. You're allowed to divide them like that. Well, 4 over 6 simplifies to 2/3. And 40 is the same as 4 times 10 in there. 4 times 10. And that means you can take the square root of 4 and multiply it by the square root of 10. So you're allowed to separate 40 into square root of 4 times square root of 10, which is the square root over each of them. Well, the square root of 4 is 2. 2 divides into 6. This becomes 3. And that just becomes a 1 up top. They both divided by 2. And notice they're all over 3 again. So we can then just rejoin them if we wanted to. And say, this is the exact answer simplified. So that's also important to learn, is how to, but we'll get to that. But the point ultimately I'm making, skipping all that simplification, is that this is the exact accurate answer. Now let's look at the inaccurate answer. We're going to take the square root of 40. We're going to add it to 4, which is the numerator. Then we're going to divide that by 6. And we get that. X on our graph, one of our x's, our roots, will be equal to that. Notice it gets inaccurate because the calculator keeps going over on and on. Now let's do the negative version. The negative version, you should have just saved your numbers from the first version because they repeat a lot, right? They repeat a lot. B is 4. We already discovered this here is 40. And we already discovered down below is negative 6. 2 times negative 3 is negative 6. We also know that the negative numbers cancel here. This negative here cancels with this negative down here. Actually, that might not be entirely true. I don't think I should have. I think I actually have to change. You know what? I don't think I can actually change. Yeah, no, it worked. So yeah, because they're separate. Yeah, it works. I think I might have had to change both of them though. It doesn't matter. Let's just keep going and see if it works. All right, so let's look at the exact answer to this. This time it's 4 minus the square root of 40. Minus, oh, I didn't do 4. 4 minus the square root of 40. Always hit your equal sign, otherwise you'll get a mistake dividing with the bottom. And we get our second root is this. Our second root is this. X is equal to this. Now let's go back to our graph and see if this is accurate. 1.72, negative 0.38. There's the negative 0.387, and there's the 1.721. So we discover that the quadratic gives our exact roots, not our factors. So that's the benefit of the quadratic. Let's lower this graph a little bit until we have a exactly on the, let's do a different one. Okay, we're going to do minus 4x squared minus 6x. No, right. Let's do this one instead. X minus 2, x plus 2, and then plus 5. Like that. So we're going to, or 4, let's do that. There we go. And we're just going to maybe, 4? No, that doesn't work. Let's do it like that. Notice that this touches the x-axis just at one point. Let's see if we can make this a little bit more smooth like that. There we go. That's a better one. Now I'm going to expand that, and I get y is equal to x squared plus 4x plus 4. And there, that's the expanded version. Notice that this was a factored version, and to do the quadratic, I need the standard format where it's expanded. All right. According to this, my discriminant should come out as 0, because when there's when a parabola or quadratic touches the x-axis in one spot, the discriminant will come out as 0. Let's do that all over again. What's my a? A is equal to 1. What's my b? B is equal to plus 4. What's my c? My c is equal to plus 4 as well. So let's make those a little bit larger so you can see them. There we go. So now we have my a, b, and c. We just need to do two versions of the quadratic. But let's work on the discriminant first. What's b squared? Well, b is 4, so b squared is 16. What's my a? 16. There we go. My minus 4 times, let's get that down to like that. There we go. Minus 4 times AC. Well, my A is 1. So if I put these into brackets, it would be like this. Times A times C. And I would just lower it a bit. Well, I discovered my A is 1 and my C is 4. What's 4 times 1 times 4? Negative 4 times 1 times 4. It's negative 16. When a quadratic touches the x-axis in one place, the discriminant will be 0. The discriminant will be 0. So we discover the square root of 0 is 0. That means everywhere I see the discriminant here, I can just put in 0. Well, that's going to make my thing easier because my discriminant is 0. I know there's just going to be one root. So I can just fill it out. Doesn't matter which one I use, but I'm going to do the same thing to show that negative positive is the same thing. So we have a negative in front times my b. Well, my b is positive 4, so that means negative 1 times positive 4 becomes negative 4. And this one's a plus. We know the discriminant is 0, so we can just get rid of it. My a is 1, so 2 times 1 is this. What's x minus 4 divided by 2? It's minus 2. If I go over here and do it again, it will become the same thing because the discriminant is 0. So it doesn't matter if I add or subtract it. It's going to be the same thing. I get minus 4 over 2 again, which is minus 2. And that's because there's only one root when the discriminant is 0. Boom. That worked great. And you might say, well, why are we doing the discriminant? If we're doing it over and over again, we have to do the quadratic again. Because if the discriminant comes out as negative, you don't have to do the quadratic at all. So let's say we're working with this line, which we know is above the x-axis. But we say, you know, I don't want to spend too much time on the quadratic. Let's see if the discriminant works. Let's see what we get for the discriminant. That means I need my a, b, and c. Well, looking at this one, a is 1, b is 4, c is 6. Replacing what's 4 squared? B squared, 4 squared, 16. And I always like to put my a and my c in own brackets in case they're negative. Times a times c. Well, what's my a? It's 1. What's my c? It's 6. 6 times 1 is 6. What's minus 4 times 6? Minus 24. Minus 24. So suddenly we have 16 minus 24. I don't even have to calculate it. That's minus 8, but it's going to be a minus number because 16 is smaller than 24. Right away, that tells me my discriminant is negative. When I have a negative, I can't take a square root of negative, which means there are no roots. That's the point of the discriminant. If you discover a negative right away, you can say there are no roots. But as you've seen with the quadratic, the problem is you must keep the symbols, the negatives and the positives, separate from the a, the b, and the c. How they should actually write the quadratic, or the quadratic formula, is this. X is equal to negative, open brackets, and it's really negative 1 times open brackets, b, plus or minus square root of b squared minus 4 times a times c, all in their own brackets, divided by 2, open brackets, a. This allows you always, you should do this anyway whenever you're filling in missing variables. This allows you to sort out the pluses and the minuses easily. Now keep in mind this plus minus here means we're going to do one that's plus and one that's minus. That's all it means. So you do two separate functions. But these brackets allow you to clearly see when something becomes positive or negative. Because if b is negative here and I multiply by minus 1, this whole thing will become positive. Same with over here. If a is negative or c is negative, this minus 4, when it multiplies it, will make this whole thing positive. Also keep in mind there's a square root there. I just forgot to draw it. Also keep in mind it's b squared here. I just forgot to draw it. So that's how you do the quadratic. Please stop, but here I'm going to go further into depth of where the quadratic came from. Let's look at the vertex format. The vertex format says, or actually even the factored format. Yeah, let's do the factored format. We know that these are the roots of this particular graph. We're just going to use our own thing. So we know this. And we also know the expanded version, or the standard format of this, is x squared minus 6x plus 8. We used it earlier. So we're going to do that. One's a factored form. One's a standard form. There's another format where we would complete the square, which you'll have to get good at. And we get x minus 3 squared. And minus 3 squared. And plus 9. Plus 9, so I have to subtract a 9. Plus 1. So that's the factored form. All these three lines are the same thing. But we're going to use a version up here for the standard form. Usually there's a number in front, right? This is the standard form with the actual numbers. But the standard form written without the numbers is this. It's a. We'd have an a in front of that. Instead of minus 6, we just say plus b. Plus bx. And instead of an 8, as soon as I get it, you don't have to continue watching this, but this is useful for your knowledge of where it came from. And then instead of 8, it would normally be a c. And when we solve for the quadratic, we often have to, we set y to equal to 0. We set y to equal to 0. So let's just do a big old plus there. Let's make my x's a little smaller too. They're a little too crazy. There we go. We'd have to set y to equal to 0. Well, that means if I'm going to solve for x, I have to get rid of all these a's, b's, and c's in front of it. The first thing I'm going to do is subtract c. So I get minus c from both sides. I subtract c. I get minus c is equal to ax squared plus bx. Great. The next thing I'm going to notice is I need to complete the square. Complete the square. Well, in this case, when I'm completing the square, I probably should just use the vertex format, but that's okay. When I'm completing the square, so we're here now. I'm going to just delete what we have so far. When I complete the square, I have to do a weird process where I factor out the a. I have to factor out the a to get the x squared all alone, which means we're left with b over a when I factor out, like this, times x. Like that. And the minus c is still on the left side, like this. What did I do? I simply divided both things by a to bring the a out front. If you were to expand this, a times x, oh sorry, there should be a square there. A times x squared, right, is ax squared. And a times b to the x divided by a, the a's would cancel out, and I'd just be left with bx. So all I did was factor out an a. So that's just to get rid of the a. So I've got to bring that square back. There we go. So now I can get rid of the a by dividing a on both sides. Just dividing a on both sides. Boom, boom. It disappears. That's how I'm getting rid of a's. Great. Good so far. Now, I now have this as a factored format, and I happen to know from my knowledge of factored format that if I divide this one by 2, I can get, and this is really advanced stuff, I can get x minus b over a over 2a will be my vertex format. X minus b over a. So essentially took the minus ba and I took the plus BA and I divided it by 2. And I also, you might say, well, why are you adding a negative? Let's see. No, I can just keep it positive. So let's just keep it positive for now. There, like that. And now I can add a square. But the problem when I do this, and this is complicated, I'd have to show you some numbers, is I now have to, and also keep in mind, yeah, but I now have to subtract, minus, I now have to subtract the square of that. It's kind of hard to understand. I now have to subtract the square of that. Squared. We can go into more detail about this. And I also have to remember, oh yeah, no, that's good right there. Now I have x all alone. So I can add, keep in mind that this is on the left side. We can go into greater detail about what happened here, and it's easier to show in a vertex format, but whatever. This is what we have now. I now have something that just has numbers over here, and I can add it to both sides. I can add it to both sides. So I get this plus b squared over 4a squared. Like that to the other side. You can sort of see it starting to take shape, but this is where it came from. You can stop this, by the way. This is just advanced stuff. And I'm left with this on the right side. Great. How do I get rid of this square? I square root both sides. I square root both sides. That gets rid of the squared. Now I've got x plus b over 2a. How do I get rid of the plus b over 2a? I simply subtract it from both sides. Minus b minus b over 2a. And you might say, this doesn't look anything like the quadratic, and you'd be right, because we have to simplify the fraction in the middle by putting them both over 4a squared. So I have to multiply this one, top and bottom, to get it over the same denominator, over by 4a. So 4a. And that means the denominator here becomes 4a squared. Getting there. Well, right here, I can also divide everything up into their own square roots. So that means I can take this square root here, and I can apply it to the top. Starting to look familiar. And I can apply it to the bottom. And the bottom I can also apply to each individual thing. Square root of 4 and square root of a squared. What's the square root of 4? It's 2. What's the square root of a squared? It's a. So down below, I get 2a. Notice that the top one is starting to look like the discriminant. I just have to rearrange it in the right order. Notice that we have two things over 2a here, here, and here. That means I can put it all over 2a. Oh, by the way, when I took the square root of something, whenever you take a square root, you have to add a plus and minus. I'll go over why that is in the future course. And now I simply rearrange this to put this up front. Minus b plus or minus this. All of it over 2a. And that's where the quadratic formula came from. It came from solving a standard formula without any numbers in it, just a, b, and c. And it's how you would solve it. You need completing the square to do it. This is very complex. It's just to expand your mind because I think you're a smart cookie.